Hi, my name's Stephen Crampton. I'm the CEO of ORDITAL, and I would like to speak to you about how we're changing the way asset information is captured and why it's important for your organisation. Companies around the world are spending literally billions of dollars building up enterprise asset management systems, or in some cases, computerized maintenance management systems to improve the efficiency of operating and maintaining their assets. And the reason is pretty simple, because every dollar that you can take out of safely operating and maintaining the assets goes straight to the organization's bottom line. A big part of the success of an asset management system is the asset information itself. You can't maintain and operate what you don't know about. So there's different types of asset information. In this little example here, I've got a car. It's the functional information about it. I've got a car, it's got 4 wheels, can take 5 passengers, it's got a hatchback. And that's the functional information, and typically that comes from engineering. Really managed very well and controlled, and usually really accurate in most organizations. The problem comes is that we get procurement and operations can then pick a product that will meet that spec. In this case here, I've got 2 products that meet that spec. Both obviously have completely different parts, maintenance strategies, skill sets. So to operate and maintain that, having just the functional information jeopardizes my ability to optimize my performance. So what it looks like in a lot of organizations, they look in their CMMS or their asset management system, and they have the functional information pretty well, but what's actually installed there at that point in time? And just because you do have some data of what was installed there at that point in time doesn't mean it matches what's installed there today, because products get swapped in and out. And the end result in a lot of organizations is they don't actually trust what's in the enterprise asset management system. And that means they can't make big decisions on purchasing or maintenance, major maintenance, based on what's in the database. Now, you could simply go, well, I'll just send somebody out there with a nice new tablet to go and enter lots of data. Why wouldn't that work? From one point of view, giving somebody a tablet is actually a lot less efficient than getting them to just scribble down on a piece of paper. It's good for the back office, for the guy in the field, not so efficient. But the biggest problem is it's not the core task of the guy out in the field. They're busy doing lots and lots of other stuff. This is just another requirement from head office that's not actually helping him do his job. But the other problem is it's really actually hard. How many of you have actually sat down and had to write down a model number and then put protective equipment on, be out in a hot, dirty, dusty environment and try to do it then? It becomes even more difficult. If I look at that Rosemount transmitter, that's a typical model number. The chances of writing that down out in the field and getting it accurate, pretty much negligible, and that's what we see. So sending somebody out to write down some data is not going to get you the accuracy or the improvements that you want. But the other thing is it's just really expensive. If you send somebody out in the field, rule of thumb is a good operator might do about 100 tags a day, probably closer to 70. But that can be $6, $7, $8. In some cases, I've seen it up to $20 an hour just to actually get people to stand in front of an asset. That's really expensive to be capturing data that's just not as good as it needs to be. So what do we do to change that? We focus on the guy out in the field. We don't want them entering data either manually or on a piece of paper or in an app. What we want them to do is just take a photo. And that simple approach makes all the difference. And it makes all the difference because that in our life is how we capture information. If you think about it, if any of you have a tradesman come to your house to install an air conditioner, nobody will tell him to do anything, but he'll whip out his iPhone and take a photo of the work he did and the nameplate, and he'll capture it, and that'll be his personal archive. So we're building on that sentiment where people capture information with photos because it's easy. But what we need to do is then turn that into information. So what actually becomes information? If I had a building full of books, that is not information. I wouldn't be able to retrieve any data from that. So what people have used for centuries is classification and cataloging, and that turns a building full of books into libraries that you can extract information from. And that's exactly what we do. We provide a mobile app that allows you to catalogue and classify very large numbers of photographs, and the classification guides people through and allows them to take very high quality photos that are consistent. That then goes up into the cloud as a big data archive that we can retrieve and query. And people talk a lot about big data, but here's a real example of what big data looks like. And when you've got big data, you need to look at different approaches for getting information at scale out of that data. And we use a thing called crowdsourcing to get measurable quality data from that big data archive. And I'll talk to you a little bit more about that in a second. So we start by planning. We want to get the data out of your maintenance system and put it up on the cloud and build work packs to guide people to go and capture the data in the most efficient way. We then send that data back onto your EAM in your standard upload template. There's a lot of different ways you can do that, but that's usually the most simple place. So we'll take out the locations and assets. We'll build work packs or lists, synchronize that with the mobile device, process the data, and send it back to you in your standard upload template. So now we've planned the work we want to do. The biggest question and the biggest thing for success is who's actually going to take the photos. This is obviously outside of what ORDITAL does. We don't take photos, but the biggest question there is who. I've seen so many projects go by the wayside when people just say, I'll just get an operator to take photos in their spare time. If you don't have somebody dedicated to doing this, then it's not a priority for them, it's not accounted properly, and it doesn't happen. So you need somebody to go through, and it's their job to do that. For a lot of companies, that's a contractor. Others, it's somebody who's been allocated full-time to do it. So when we go out to collect it, we've decided who's going to collect it. We're not just interested in capturing the photos themselves. What's just as important is the metadata, because what we're trying to do is build up trust in our database. And that trust comes through by the time and the location and who collected it. If I know it was captured last year and where it was, that gives me a lot of trust. If I don't know when it was captured or it was captured 10 years ago, that gives me a lot less trust. The other thing I want to do is to be able to capture assemblies. My maintenance system, I might just manage a control valve. But that control valve or the pump is actually an assembly of a whole bunch of components. In control valve, I might have an actuator, a positioner, a solenoid valve, etc. And I need to be able to capture those because the last thing I want is people putting the actuator on the valve, the pump motor on the pump unit, because I want to actually know the make, model, serial number. And this allows me to start to look at building up bombs as well. So what we allow you to do is just a one-click capture and create any of those components and make sure you're putting the nameplates in the right spot. So we go through, we capture all the photos, and this is the big thing, is that the capture exercise is actually capturing the classified photos. So without any processing, I know that I have vendor information, manufacturer nameplate information, I have a few components such as a motor and a drive, and I have tags and equipment photos. I know all of that without processing any data. I can do that really, really quickly, and the way we do it, where we segregate all of those data with classifications, means I get very good photos, very reliably, without people trying to stuff everything into the one photo and making it confusing. It means without looking at any photo, I know what data is in that photo and what I'm likely to be able to get out of it. Then, at any time in the future, I don't have to do it immediately. I can take the photos, and then maybe 6 months later, I want to extract data from those photos. In this case here, I've extracted the nameplate information from the pump, and I've extracted the vendor data from the pump. Now, all of that can be done at any time. I don't have to do that at once, and I can come back later and grab any other data I want. So how does that crowdsourcing work? What we do is we pay people in a crowdsourcing network to answer questions. And we ask lots and lots of questions, and we get lots and lots of judgments, independent judgments from different people. And consider a single judgment might be somebody entering our serial number. So if I've got 3 people keying in exactly the same serial number, then I'm very confident that that's the serial number. So we aggregate all of those crowd judgments onto the individual photo from where they came. We obviously have lots and lots of photos per asset, and then we aggregate all the data from the photos onto the asset themselves to give us data that we're very, very confident in, and it's measurable quality. These jobs we use in the crowd network, we have access to millions of on-demand workers spread across a couple of hundred countries, and the jobs are executed literally all over the world. People get paid for their work. We only want the very highest quality workers, so we bid for that work in an open market. If I put ridiculously low prices on that, people won't respond to it, so we need it done quickly. And the jobs get smarter over time to guide the workers to reliably give us really good data. But it's not just text information. We can go and ask any question. So in this case, I've got a water meter for a water client. They're looking at replacing their water meters with smart meters. So we want to get an idea of the cost to replace that. So we have the water meter readers taking photos, and we can ask lots of questions. So one of the questions was, is it buried? And we gave some parameters to the crowd, and half said it was buried and half said it wasn't. Same as in a pit, we showed them examples of manufactured pits. Some said this was a manufactured pit, some said it wasn't. And you can see it's a question there. It's not black and white. But one of the other things I wanted to know was the pipe, if the pipe is copper or the pipe is galvanized iron, there's a different cost to change that meter over. So we look and see whether it's got a green tinge in the pipes to see whether it's copper or whether it's galvanized iron. So everybody that looked at that, so I don't even need to look at those photos. I can see from the data with confidence that it's got a butterfly handle, that it's low, that it hasn't got concrete or brickwork below the meter. As to whether it's buried or not, that's a question I might want to review again, but I know it's definitely a low meter and it's probably borderline. So we're coming and introducing this concept of measurable quality, in that we're asking lots of people and we're able to measure the confidence in the results. And if the confidence was too low, we could go back and ask for more judgments to get the confidence levels we want. What you'll get out of that raw data extraction, you'll get what people see. But the nature of what we're doing is that the equipment's been installed outdoors in hazardous environments, and usually for some period of time. So that gets damaged and corroded over time. So what you find is Q's and O's and zeros are really hard to distinguish, and B's and 8's and S's and things like that. So the nature of it, people will enter what they see, and it might be corroded, and they'll use their best judgment, and we'll get it from there. But there's lots of other data sources we can compare against. So in this case here, we got the photo which said it ended in A62, but in the customer's supply chain, they purchased a whole bunch of serial numbers that ended sequentially there with a 32. So if I look at that photo again, I say, well, I can actually see it's a 32. So what we've got is the ability to look at a whole bunch of different patterns in the fleet and compare with known data sources to see whether or not our data that we've extracted is accurate or not. The nature of this business is that people don't just buy one-offs, they buy 10 of this, 30 of that, 20 of this. And by using patterns within an individual customer's fleet, but also within looking across all of the ORDITAL database, we can identify anomalies pretty quickly. One of the biggest anomalies we need to deal with is whether the companies that manufactured the equipment exist or not today. So one of the big things we're doing in post-processing is identifying and making a connection between the asset and the product. The manufacturer makes a product and the operator operates an asset made of products. So what we want to do is build a connection. And the reason we want to build a connection is what's on the nameplate was accurate at the time the equipment left the factory. However, that changes over time. It's not a static thing. It's temporal. It has a start and an end date to its validity. In our asset management systems, we tend to manage things as if they never change, and they do. Rule of thumb is if your facility is 10 years old, probably half of the companies related to that asset don't exist anymore. In this case here, it was a valve that was made in 2004 by PBV USA Inc. That doesn't exist anymore. It got bought and sold several times and is now a brand of Forum Energy Technologies. So we want to keep up to date on that. There's lots of companies that are connected that we'll call the ecosystem. It's not just the manufacturer. There's the vendor who you bought the product from, or in the case of a pump, might have assembled it, or a control valve. The inspector, let's say in the case of a pressure vessel, who every few years needs to certify it. Or the service contractor who comes and services in an outsourced maintenance effort, even down to the operator itself, if you buy and sell those assets yourself. So what we do is we connect that to the ORDITAL database of companies and brands, and that database is synchronized with the Dun & Bradstreet database that is updated every single day. So we can track whether the company's been bought or sold on an ongoing basis to be able to report on any of those changes. So a way it would work, I showed before, taking a photo of a pump and a nameplate of the vendor. So that's the information that we captured. We connect that to our database and we see, well, Southern Cross is actually now a brand of Pentair, and Rob Lane Pumps doesn't exist. It was bought out by Brown Brothers Engineers. So we have all those database records in the ORDITAL database, which are kept up to date on a daily basis from the Dun & Bradstreet database, links through to their websites and all their addresses. So all that information is available to keep your supply chain up to date, but also to know if you're operating assets that are no longer supported. Usually when there's an acquisition, there's usually a product consolidation as people merge new products into their new assets. Sometimes even all the spare part numbers might change as they merge them into a new ERP system. So what we're able to do is then go through and run queries. So in this case here, it was a valve, Silvani, in Italy that was sold by UTC Fire and Security, and it was purchased by Finvalve. So we can say, do a query, show me all criticality, number one critical assets that have had a change in their ownership in the last 6 months. So once we've got that data, we've linked it through. There's a number of ways that we can move it back. We're built on standard platforms, so there's lots of plugins, but nobody's ever done that. Just because it's possible doesn't mean you should. Excel templates in and out are the simplest way, and that's how we do it. ORDITAL has been around for a few years now. We've been doing projects in oil and gas, utilities, and building facilities. We've been doing projects with some of the biggest companies. We're based in Australia, but we're doing projects in Australia, North America, and Europe, across a whole range of industries. A lot of these are repeat projects, so that as people get more and more work, they now do all of their data capture through the ORDITAL solution. So increasingly moving through all these projects with these customers. And the reason we do that is economically it works. If I compare a traditional audit and one using ORDITAL, traditionally you could do about 100 a day, let's say. Our clients typically do about 300. Sometimes it's 200, sometimes it's 500. Depends on how close the assets are to each other. But the person you send out there traditionally needs to be an expert. He needs to be able to accurately get all of the data off a nameplate. We just send somebody out to take photos. I don't need them to understand what's in the nameplate. I just need to say, well, okay, here's a photo of the motor nameplate. Here's a photo of the pump nameplate. And that means it's a lot cheaper per asset to get the data. But also we're in and out 3 times faster. So from a safety point of view, you haven't got people wandering around your facility. In the traditional way, you'll have people out in the field. They need to come back and load photos and enter data in databases. That has a cost. For us, it's just synced as they're walking around. Then, obviously, in the traditional one, they've already entered all the data in the field. They don't need to extract data. We would extract data. There's a range of costs per photo and how you do that. I've just given a typical example there. That can vary. but that would be, I guess, the average one. Whichever way you do it, you're going to have to post-process the data. We'll assume it's the same. I believe we would be significantly cheaper because we're able to leverage our database. But even so, it leads us to being about 40% cheaper. 3 times faster, more accurate, and about 40% cheaper than you could do it by traditional methods. But once you've established that data archive, you can use it for so many things. You can start to embed photos in your work orders and make them available to your workers, so there's no ambiguity. You can use it for troubleshooting to be able to communicate where there might be a problem. You can also go and, let's say, for an efficiency drive, in this case here, I've suggested air conditioners, but if you had electric motors and wanted to look at power factors, you could decide, well, I need more attributes, and you just run that without having to send anybody else out to the site. So the project gets done quicker, safer, less disruption to the organization, costs are reduced significantly. Additional projects don't require revisiting. We're fully describing the asset with classified photos. You're not actually going to learn anything different by sending somebody out to the site again. And it's much more accurate. We've got multiple people and we're delivering measurable quality. So it's higher accuracy, faster projects, lower cost, and that's why people are changing the way that they're capturing asset information with ORDITAL. Thank you. Happy to answer any questions. Please contact me on my contact details on here. Thanks for your time in listening to this today.